Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the object-oriented programming, and the new chapter, that is chapter number 13, that is exception handling. In the last class we have discussed or we have finished with the chapter number 12. We have discussed so many practical topics, that is the programs of chapter number 12, that is a function template and the class template. We have finished with the function template as well as the class template, that is we have finished with the chapter number 12, that is templates. Now today I am going to continue with the same module but with different chapter, that is a new chapter, that is a 13th chapter, that is exception handling, and this is one of the important chapter that is a part of the C++ object oriented programming. So let's continue with the previous class session, revision of the previous class session, and then continue with the chapter number 13, that is exception handling. So in the last class we have started with the function templates with the multiple arguments, and what are the function template and what are the class templates. We started with the class template with multiple parameters, that is there are more than one parameter that is available with the class template. That is the first topic that we have studied, that is a class templates with multiple parameter, that is more than one parameter is used at the same time. Taken about that how to use the class templates with the multiple parameter, that is how to install them and how to use them with multiple parameters. So there are multiple parameter like class T1, class T2, there are multiple parameter in this class template. This is the example that we have studied about. Then we have talked about the function template. Now what is a function template? Till now we have covered the class templates. As we have started with a template concept, that concept shows that template is the collection of, or template is a collection of the classes and the function, or the group of the classes and the group of the functions. So functions are divided into two categories. One is the function templates, sorry, the templates are divided into two categories. One is the function templates, one is the we can say the classes or class templates. So there are two categories, function templates and the class templates. So we have finished with the function class template, that is a combination of various classes. Now next is the function template, that is a combination of various functions. So like class template, we can also define the function template that could be used to create a family of functions with different argument types. That is, argument types are different, but it is a collection of various functions, that is a family of functions with different argument types. The general format for a function is template is. So what is the general format? This is given as a general format, that is given the template that contains the various functions but with different argument list. That is a family of functions with different argument list. Now the general format for this one is this one. There is a template class T, then return type, function name, arguments of type T. That is a template class T, that is the first line, that is a common line that is used, that is a template class T. Then there will be a return type, that is a return type of the function. Then there will be a function name, that is a name of the function. Then argument of type T. That is, the argument is given of the type T, that means the argument is given for the function T. Then curly braces start, then there will be a body of the function with type T wherever possible, that is wherever possible the function will be operated on the type T. The function template syntax is similar to that of the class template, that is it is very similar to the or syntax is very similar to the class template, but the main difference is that we are defining now the function instead of classes. That is, there is no concept of the class but only defining the functions. We must use the template parameter T as and when necessary in the function body and in its argument list. So we must use the function template or the template parameter T whenever it is necessary in the function body. The following example declares a swap function. So there is a swap function template that will swap the two values or the two values of a given data. That is, this is a function, this is a program that shows a function template, that is a function that shows the swapping of a function. Swapping means interchanging the values of a function, that is a swapping. So this is starting with the template class T. Then void swap, this is the function, this is the return type of the function, that is a void. Then Name of the function, that is a swap, then t ampersand of x, t ampersand of y. That is, there are two concepts, that is the ampersand of x and the ampersand of y. That is the address of x and the address of y, and both are using the t as a parameter. Then using the temp variable, that is temp equals to x, that is the t is also used as a parameter. Now the temp variable contains the x value, that is the x value is stored in the temp variable. Now uh, the x is now empty, that x variable is now empty. Now stores the or put the y values into the x, that is taken the values of y and stored in the x. Now y becomes empty, so take the value of the temp and stored in the y. So this is interchanging the value. Automatically the x contains the y value and the y contains the x value. This is the swapping that we have covered. So this essentially declares a set of overloaded functions, one for each type of data. That is, there is a swap function that is used that takes two arguments, one is for x, one is for y. We can invoke the swap function like any ordinary function. For example, we can apply the swap function as follows. This is the example of how to apply the swap functions. There is a void f, this is the return type, then the name of the function is f, and there are multiple arguments that is given, that is a int m, int n, float a, float b. And there is a swap function that is used to swap the two integers value. How do I know to swap two integers value? Because m and n are of integer type, and we are passing the argument as an m and n. And again there is a swap a b. Again there is a swapping of the two float number, that is the a and the b. Then we have talked about how to apply or how to generate or how to use the function template with a single we can say the single function, that is how to use the function template with only one parameter. So there are first of all header files, that is the hash include, iostream, iomanip and the cmap. There are three header files in this first of all. Then there will be a first line that is same, that is a template class t, that is exactly the same line, template class t. Then the return type, that is a void, and the function name, that is a roots, and there are three argument that is given, that is ta, tb, tc. Now curly braces will start. Now td, that is the next variable, that is also of the t parameter, that is a d variable, that is equals to b square minus 4ac. That is, first of all we are taking the values of, we are multiplying the values of b into b, that is b square, that is minus 4 into a into c, that is whatever the value of a, whatever the value of c, that is multiplied together, and that will be multiplied by the 4. Then it is starting with the if condition, that is now check the condition for the d, that is if d equals to 0. So what's the output, or what is the output, that is output that is come from the b square minus 4ac. If the output is 0, that means the roots are equal. So this is a program that shows how to calculate the quadratic equation. So on the basis of the d, if it is equals to 0, then we can say that the roots are equal. Then if d is greater than 0, that if it is greater than 0, so we can say that roots are real. And if it is less than 0, neither equals to 0 not greater than 0, if it is less than 0, we can say the roots are imaginary or roots are complex. So there are three conditions. One is d equals to 0, one is d is greater than 0, one is d is less than 0, that is a minus. So in the first, when the d equals to 0, then simply prints the roots, that is r1 equals to r2, that is root 1 is equals to the root 2. Then minus b divided by 2a, that is a condition, that is we can say the output that is generated, that is minus b, that is divided by the 2 into a. Now else, if the d is greater than 0, first of all it is equals to 0, next it is greater than 0. If it is greater than 0, then roots are real. Then float r, that is equals to square root. Now finding the square root of the d, that is the sqrt function is used. That's why we are using the header file, that is cmath.h, that is sqrtd. Then float r1, that is the r1 will be used as a float r1, and if d is less than 0, then roots are complex. So these are the three conditions that is available for the d, that is your determinant. In full form of d in the math in quadratic equation is determinant. So the three condition: equals to 0, roots are equal; greater than 0, roots are real; greater than less than 0, roots are complex. Then starting with the int main, that is the main of the starting, that is the int main. Then cout integer coefficient, that is the cout integer coefficient, that is printed as it is. Then the function will be called, that is the 1 and the 5 and the 6, that is there are three parts: 1 comma minus 5 comma 6. Then cout float coefficients, in the same way a function will be called, that is 1.5, 3.6 and the 5.0. Then there will be a return 0. So from this the roots will be considered, that is the roots will be occupied, that is 1, minus 5 and the 6, and the cout float coefficient, that is 1.5, 3.6, 5.0. Then this is the output. Then function templates with multiple parameters, that is more than one parameters are used with the function templates. That is this is the syntax that is used, that class T1, class T2 and so on. So there are multiple templates, multiple parameter that is given in this, we can say the as a parameters. Then in the next line there is a return type, then function name, then arguments of the type T1, T2 and so on. Then body of the function, that is a main function, that is a body of the function. Then this is the function with two generic types. This is the example, that is how to use the function with two generic types. That is, in this there is a class template, there is a template, then class T1, class T2. Then void display, that is the name of the function in display, and the return type is void. Then there are two arguments, that is a multiple argument, that is T1x and the T2y. Then cout x and the y will be printed. Then int main, that is the starting of the main. Then the display function will be called, this is the calling function, that is a display. This function will be called to pass the argument. So this is the integer value, this is the character value. So now the x value is 1999 and the y value is ebg. Another function is display function. The first value is 12.34, another value is 1234. So this will be displayed like this one. Then we have discussed about the overloaded function template, that is one function can be overloaded. This is the example of the overloaded function. There is a template display, this is as it is display, that is a display function. There is a int x that overloads the generic display. Then cout explicit display. So this is the void display tx, then cout template display, then void display int x, then cout explicit display, that is the x value. Then int main, that is the starting of the main. Then the display function will be called, that contains first of all the integer value, that is 100, then the float value, that is 12.34, then the character value, that is a c. And then there is a non-type template argument, that is there is no type of the template argument, there is no predefined type that is available, that is a non-type template argument. This is the best example of the non-type template argument, that is taken the value, that is initialize the value, that is automatically array initialization. Then there is a summary of this chapter, that is winding up of this chapter. And these are the various questions of this chapter. Now let's move to the practical approach of this chapter. then v equals to new, that is a new operator will be used, that is v equals to new, then t, and then there will be a size of the on the size variable, that is 3. Then the for loop will be used, then int I equals to 0, I is less than size I plus plus, then vi equals to 0. Then next function will be used, that is a vector, then in parenthesis it is used, that is a t, pointer a, then for loop will be used, that starts with the 0, then vi equals to ai, then this will also be closed. Then the next one is again taken as a vector, now not vector, now it is taken there is a t, then operator, then there will be a pointer, then vector ampersand of y, then t, then sum equals to 0, then for loop will be used, that is int I equals to 0, I is less than size I plus plus, then sum equals to, or sum plus equals to this, then arrow vi into y dot vi, then there will be a return sum, that is the sum will be returned. Then this is the closing one, then the class is also closed. Now there is a int main, that is the starting of the main, then one array will be declared, that is equals to 1 2 3, then y, that is equals to 4 5 6, then vector v1, then vector v2, now v1 equals to x, then v2 equals to y, then one r will be declared, that is a array variable, or we can say the variable r, that is v1 into v2, then cout, that is the r equals to, so in this that is r equals to, in double quotes, there will be r, then there will be a get ch, then there will be a return 0. Now if I compile this code, there will be a warning, that is the function containing 4 are not explained in line. That is, it is not explained in line, that is, it's not taken in a line, that is the size will be used. Now this is the size, this is the size, that is 3. If I execute this code, the r is 32, that is the r value is printed as a 32. There are 2 times the r value will be printed, right? So this is the example of the template, the first example of the template, that is how to use the templates in the C++. So let's start with this one. First of all, save this file, that is a template. Now first of all, there are 2 header files, that is the iostream.h, then the conio.h. So these are the 2 header files that is used. Then constant, that is a constant variable will be used. Then size equals to 3, that is a constant, means the value of the size, that is a 3, is remain constant throughout the program. That is a size variable contains the number 3, that is a size equals to 3. Then template class t, this is the predefined line that is used. Now let's see, if I'm not using this line, that is excluding this line, so what is the impact? There are 9 errors believe, because every time the t will be used, it will show the error. This is also error, this is expected, this is this one. So these are the all errors that will be used. If I include this one, there will be no error. So believe, or see, this is the main thing that is used. If I compile, this is the r equals to 3. There is a null point assignment. If I close this one, again moves to this one. If I again moves to the template example, let's see what happened. First of all, there are header files, then const equals to this, then class vector that is defined, that is a t pointer v, that is including the pointer v. Then there will be a public, there will be a vector function, that is a vector function will be used. Then v equals to new t size, that is a new function will be used. Then for loop will be used, that start with the 0 and with the size, and there is I plus plus. Then vi equals to 0. Then there will be a closing of the curly braces. Then the next function will be used, that is a t pointer a, that is a pointer of the a. Then for loop will be used again. They start with a 0 and with the size, and there is I plus plus. Then again vi equals to ai, that is whatever the value of ai that is stored in the vi. Then the next function will be used, that is a t operator pointer, that is a vector ampersand y, that is sum equals to 0. Then start with 0 and ending with the size, then there is I plus plus. Then sum plus equals to this arrow vi into y dot vi, then return the sum value, then closing. This is also correct, v1 v2 v1 into v2, then the cout r, right. Now if I compile, the value will be displayed, that is r equals to 33 32. there's no issues. Now I have to include the clear screen. Now if I compile, there will be R32, there will be a 32. If I again compile, there will be R32. So this is that is used. First of all, there are two header files, that is the hash include iostream.h and the hash include conio.h. So these are the two header files that is used in this program. iostream is used for the basic functions and the conio is used for the getch function. Right. Then variable will be declared, that is a size that contains the three values, that is a constant that remains the same throughout the program. Then class vector, then the t is used as a parameter, there is a pointer v. So one pointer will be used, that is a v. Then in a public there is a vector, that is a vector function is defined. In this, first of all, dynamically allocates the memory for the t, that is a v equals to new t, then size, that is a there are three blocks of memory that will be used, that is a that is used for the t, that is a t size, that is a 3. Then uses the for loop that start with the 0 that ends with the size, then there is a I plus plus. Then vi equals to 0, that is it is ending, or it is a we can say the beginning with the 0, we can initialize the vi equals to 0. Then vector t pointer a, then the next function that is used, that is a vector t pointer a. Then it's there is a for loop that start with the 0, that ends with the size, and there is a I plus plus. Now initializing or passing the values of ai into the vi. Every value of ai will be passed to the vi. Then operator will be used, that is a asterisk operator, that is a vector ampersand of y that will be used. Then t sum equals to 0, that is the sum operator or the sum function or the sum variable will be used, that is equals to the 0. Then for loop will be used, that start with the 0, that ends with the size, there is a I plus plus. So there is a t operator pointer vector ampersand of I. Now sum plus equals to this arrow vi into y dot vi, that is a sum will be used, or the sum variable will be used, that contains this pointer that takes the value of vi and multiplied by the y into vi. Then there will be a return sum, that is the ending of the sum or the returning the value of the sum. This is in one class, this is one function that is used, this is another function that is used. Right, then there will be a closing of this class and there will be a semicolon of closing the class. Then there will be int main, that is the starting of the main, that is the int main. First of all, it contains the array variable, that is the x3. So x3 is the one array variable that is used, that contains three values, that is a 1, 2 and 3. In the same way, defining the another array variable, that is a y, that also contains three values. This its superscript or the subscript or the its index is also 3, that also contains three values, that is a 4, 5 and 6. Then there will be a clear screen for clearing the screen. Then there is a vector int v1, that is a vector int v1 that is used. Then vector int v2 that is also used, that is a vector int v2. Then next this is that is two vector variables are declared, that is a v1 and the v2. Now initialize the value or assigning the values of x into the v1, that is every value of x, that is a 1 to 3 will be assigned to the v1, and every value of y, that is a 4, 5, 6 will be assigned to the v2. Then int r, that is equals to v1 into v2, that is one array will be declared, one variable will be declared, that is r, that stores the output of the v1 into v2. Now let's see, v1 contains the 1 to 3 and the v2 contains the 4, 5, 6. Now 1 will be multiplied by 4, 2 will be multiplied by 5, 3 will be multiplied by 6, that is 1 into 4, 4 plus 2 into 5, that is 10. So 4 plus 10 plus 3 into 6, that is 18. So 18 plus 10 plus 4, that is your 32. That gives the output as a 32 stored in the 32, and this will be displayed over by using the cout. There will be a get ch for output, there will be a return 0 because we are using the int main function. So if I compile, there will be output, that is 32, that is 1 into 4 plus 2 into 5 plus 3 into 6. So the r equals to 32. The system is again hanging up, right? So that's all for today's session. In the next class, I am starting your next topic. In the next class, I am starting your next topic. That is your next chapter. That is your exception handling. So that's all for today's session. Thank you so much, everyone. Bye bye. And if there is any doubt, you can ask the doubt from me. Thanks a lot, everyone. Bye bye. One more thing, now your class is on Monday, so on the Monday I will be starting your next chapter, that is chapter number 13, that is exception handling, and this is one of the important chapter of C++. So thanks a lot, bye bye.